Good afternoon, 8th graders. It's Mrs. Thompson, and we are going to talk about elimination today. This is our third and final strategy for solving systems of linear equations. As you may recall from section 5.1, our first strategy was graphing, where we graphed two lines and looked for the point of intersection. The second strategy we learned in section 5.2, and that was substitution. And we didn't graph, we just did things mathematically to solve that, and that process was substitution. Well, today, guess what? We're going to do one of my favorite ways to do systems, and that's elimination. So example 1, elimination using the addition of these two lines is going to be our strategy for today. So as you can see, let's look at this very first one that you see here. I put a line under it. X minus 2y equals negative 19. 5x plus 2y equals 1. Now notice that they are in standard form. Both of them are in standard form. This is the perfect form for elimination. So anytime I see two equations in standard form and they're asking me to solve that system, I would guarantee almost 100% of the time I will choose elimination. And so what you're looking for, let me kind of just feast your eyes on this second set of numbers. See, what you need is the x's on top of each other. So you've got 1x on top of the 5x, and you've got minus 2y over plus 2y. Your equal signs are over the top of each other, and your constant numbers are over the top of each other. The negative 19 is on top of the 1. That's perfect. You want that alignment. You want the x's on top of the x's, the y's on top of the y's, the equal sign on top of the equal sign, and the constant number on top of the constant number. What I'm trying to convey to you is that when you have standard form, they really should be on top of each other in the exact same order. So if your y's and x's are inverted in one and the opposite way in the other, you need to get where the x's are on top of the x's, the y's are on top of the y's, okay? Well, in this very first example, we have that situation, and what you're visually looking for are opposite numbers, okay? Now, what do you remember about opposite numbers? I hope I've said this and wore it out, but opposite numbers always add up to be what? And I hope you said 0, because that is what happens. So if I asked you, what's negative 7 plus 7? You would say 0. What's 2 plus negative 2? 0. 1 plus negative 1? 0. Opposite numbers always add up to be 0. And that's what we're looking to do in this kind of concept of elimination. We're trying to eliminate one of the variables. And so we're going to do so by addition. So we're going to add these two together. Now, why am I choosing addition versus subtraction? Well, remember what I just said. Opposite numbers always add up to be 0. So if you see opposite numbers in front of one of your variables, then you need to add those two equations together. Let me show you what happens when we add. Let's start with the x's. 1x plus 5x is 6x. So I'm adding those like terms. They are like terms. They're both x terms. I can add them together. Just add the coefficients together. What's negative 2y plus 2y? You're right. You should just cross those out. Those numbers are opposite numbers. We're going to end up with 0y, which in essence is just 0. Drop down your equal sign, and what's negative 19 plus 1? You're right, negative 18. So that's the beautiful part of elimination, is that's the goal. Eliminate one of the variables. That's our goal. Look for opposite numbers. All right, now we have 6x equals negative 18. From here, it's one step to figure out what x is equal to. So we're going to divide each side by 6, and then we've got x equals negative 3. Now remember, just as in the other two video series that we did in section 5, we're not finished. We're looking for a point of intersection. Remember, a point is The first number is x, the second number is y. We're looking for a point of intersection. We only know half the point. So what we need to do is go back to the original, one of the two original problems. It doesn't matter which one. I like the top one. So let's do x minus 2y equals negative 19. And now what we're going to do is we're going to take that negative 3 and we're going to plug it in for the x. So now we've got negative 3 minus 2y equals negative 19. This is a two-step equation. So the first thing you need to do is move the negative 3 over to the other side. All right, so now I have negative 2y is equal to negative 22. Oh, excuse me, I added wrong. Negative 19 plus 3 is negative 16. And then divide each side by negative 2. And y is positive 8. And so my point of intersection is, remember, x is negative 3 and y is positive 8. This is the point of intersection. If I were to graph these two lines would crisscross at negative 3, 8. Okay? You can check it. Take the x, negative 3, plug it in for the x. Take the 8, plug it in for the y in both equations and see if it works. You can check that out. Now, we can do that right now. We've got negative 3 minus 2 times 8. Well, negative 3 minus 16 is negative 19, so that checks out. 5 times negative 3 is negative 15. 2 times 8 is 16. Negative 15 plus 16 is 1. It checks out. So this is something you can do in your calculator. You can do it mentally if you're real good with your mental math. If you're not quite sure, you're kind of spotty with your mental math, you might want to check it with a calculator. Okay? All right, let's look at this second one here. I'm going to kind of draw a line so we can separate the board just a little bit. And I've got my y's are on top of each other, my x's are on top of each other, my equal signs are on top of each other, and my constant numbers are on top of each other. So that's good. That's a good setup. Even though the x's don't come first, it's okay as long as y is on top of y, x on top of x, equal on top of equal, constant number on top of constant number. It's okay. Just make sure the alignment's there. Now, what we're doing is we're looking to see if we have opposite numbers. Hey, looky there. I have opposite numbers in front of x. I have a positive 3 and I have a negative 3. Well, you know what? The only way to cancel out opposite numbers is to add the two equations together. So what's y plus 2y? You're right, that's 3y. The x's should cancel out because 3 plus negative 3 is 0. Drop down your equals, and then what's negative 2 plus 14? And hopefully you said 12. All right, one-step equation from here, divide each side by 3, and we just figured out y is equal to 4, okay? So we're looking for that point of intersection, so that's the y. The 4 is going to go in the y position. Now we need to go back and find the x. So pick one of the two original problems. I like the top one, y plus 3x equals negative 2. I'm going to take that 4 and plug it in for y. 4 plus 3x is equal to negative 2. It's a two-step equation. Take away 4. Here we go. Now we have 3x equals negative 6, and then divide each side by 3. And you're going to get x equals negative 2. And there's your answer. There's your point of intersection. If I were to graph these two equations on a coordinate plane, they would crisscross at negative 2, 4. So you can check the answer, take the negative 2, plug it in for the x, take the 4, plug it in for y, and check it out yourself. I'll do that real quick for you. Y is 4, x is negative 2, so that's 4 plus negative 6. Yep, that's negative 2. 2y, that's 8. Negative 3 times negative 2 is 6. 8 and 6 is 14. So that they both check out. I know for a fact that this is the point of intersection. Okay, that's it for elimination using the addition of the two equations. If you have questions, write them down, bring them to class tomorrow. Thanks for listening.